Okay, now we are looking at 1A.5. This is your last video for target A. And it says, I can simplify an expression by using the power rule to raise exponents to an exponent. So again, the big thing we're looking at here is what we call our power rule. Okay. Just like when we were multiplying our things together, we're going to start by expanding these things to kind of see what our rule is first when we have nice whole numbers before we try to get to these fractions. Okay? So if I have x cubed squared, really what that says is it's x cubed 2 times, right? So I take this twice. And just like we did in our last one, what this means is x times x times x, and then times x times x times x. So if we look here, I really have 6 x's, right? Yes. Double checking that. Okay, so x cubed squared is x to the 6th. 2x squared to the 5th, right? I'm going to take this 5 times. So I have 2x squared times 2x squared times 2x squared times 2x squared. 1, 2, 3, 4. Yeah. 5. Okay, so I'm writing that out 5 times. And what that means is, right, 2 times x times x times 2 times x times x. I have 1, 2, 3, 4, 5. I'm going to multiply all my 2's. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Feel free to use a calculator. 2 times 2 times 2 times 2 times 2. 32. Okay? And then we're going to count our x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 32x to the 10th. All right, our last one is x to the 5th, y to the 4th squared. So we're going to have x to the 5th, y to the 4th, times x to the 5th, y to the 4th. If I write this all out, we have 1, 2, 3, 4, 5. And then I'm going to write this one underneath it. So I have another 5 x's, whoops, and 4 y's. All right, so a lot of writing down of x's and y's. So 5 x's, 4 y's, and then another 5 x's, and another 4 y's. So if we think about how many total x's and total y's we have x to the 10th, y to the 8th. So again, we're looking at this rule and thinking about what we have and what we're actually doing. Okay, if I didn't expand and I just saw 3 and 2, how do I get to 6? Well, 3 times 2 is 6. 2 times 5 is 10. 5 times 2 is 10, and 4 times 2 is 8. Okay, so before, when we're multiplying, right, 3 plus 3 is 6, right, we add. But if we just have the powers, we multiply. Okay? And that is our rule here. Our power rule states, if raising a power to a power, multiply the exponents. So we have x here. Our base still stays the same. We have a 6 and a 1/3. So again, we are multiplying those exponents. So again, now that's x 6 times 1/3. Again, you can just use the division button as your fraction bar. You can literally type it as 6 times 1 divided by 3, and you get 2. Again, this 2 should still be an exponent. Be very careful with that. All right, looking here, we have 25, technically with a 1 on it. So this is 25, and then it has 1 1/2. Okay, this 8 has nothing to do with this 25. They do not go together that way. Okay, that 8 is only on that x. And then the x, make that more squiggly, has the 8 and the 1/2. Right? So here's where it gets weird. 25, 1 times 1/2. 25 to the 1 times 1/2. This chunk right here has no variables. Right? That means we type it in our calculator. So I have 25 to the 1 times 1/2. Nice. Let me get 5. Here's a variable. We cannot type variables in our calculator. This section also has no variables, so I can do 8 times 1/2, which is 4. And those are exponents, so they go here. So we get our answer of 5x to the 4th. All right, example 3 and example 4 are very similar. So at this point, pause your video and try example 3 and example 4. See if you can get the answers for those, and once you have your answer, you can go ahead and check. Okay, so go ahead and pause. At this time, you should have an answer for example 3 and example 4. You should have tried them on your own. So let's go over them. Example 3 is just like example 1. I have just the 1 base. And then it has its exponent of 10. And then outside is 1/4. Again, this part has no variables. We can't type variables into our calculator. But 10 times 1/4 is 5/2. And I'm going to be very careful that that 5/2 is up and to the right of y. It should not look like this. That is wrong. Don't write it like that. Make sure it's smaller and to the right. If you need to write your y's bigger so that that can be smaller, I'd rather have an answer that big than you write something like this. This is way more correct than this is, okay? So be very careful with that. Example 4, 27a to the 9th, all to the 1/3. This is just like example 2, right? I have my 27. It has an exponent of 1, and then the 1/3 on the outside. And then we have our a, which has an exponent of 9 and the 1/3 on the outside. Okay. Now, thinking about how we can type things into our calculator, 27, 1 to the 1/3. Again, 27 times, not times, to the 1 times 1 divided by 3. Right? So you should have gotten 3 in your calculator there. And then a, 9 is a variable, right? Can't type variables in. 9 times 1/3 is actually 3. Okay. Alright, if you did not get these, especially like just struggling with how to type things in your calculator, raise your hand, ask any questions you have from your teacher. Otherwise, if you got those and you're like, I get it, let's look at the next page for a few last examples. Example 5. This looks a little crazy. C to the 12th to the 1/4 to the 1/3. Okay. It looks crazy, but it's no different. I have my base, and my base just has a bunch of exponents, but the rule is the same. I'm just going to multiply all of them. Right, so I can't type a variable in my calculator. I'm typing all of these in. So I have 12 times 1/4 times 1/3. And I get 1. Remember, we don't have to type that 1 in, so really our answer is C. Okay, we don't need that exponent of 1 in there. All right, example 6, 7, and 8. Apply our rules from our last two activities. It looked at rules from 1A.3 and 1A.4, as well as these. So looking at example 6, we have powers and we have multiplication. So we need to remember our order of operations. PEMDAS, right? Parentheses, exponents, multiplication and division, and then addition and subtraction. So there's nothing you can do actually inside the parentheses, so the first thing we have to deal with is these exponents. Okay, so I'm going to do the same thing I did in example 2 and example 4 in the last one. I have this -4, and it can be raised to the first power and the third power, right? One, that's supposed to be a times that got connected there. And then we have our x, and it has a 4 and a 3. Now, times, we have a 2, and it has a first power, right, and a second power. And then we have this x, and it has a 5 and a 2. The one thing we have to be careful of with powers is when we have a negative number, you need to make sure when you type it in your calculator, parentheses go around it, or else it will give you a wrong answer. If you type it without the parentheses, it will raise 4 to the third, and then just make it negative, versus raising -4 to the third. Sometimes it will give you the right answer, and sometimes it'll be wrong. So if we put parentheses, we'll always be right. So what am I simplifying right now? Right, this has no variables. I'm going to type that in my calculator. So I have -4 to the 1 times 3, right? That's -64. Variable, can't type variables in. 4 times 3, 12. Okay. I'm going to skip the calculator part. If you still need to use it, fabulous. But just to save some time, 2 to the 1 times 2. Right, again, this has no variables, so that's 4. Can't type x in. And 5 times 2. Sorry, 5 times 2 is 10. Alright, now what are we doing? Now we're doing a multiplication problem. I'm going to pull my two numbers forward. Alright, just like we did in 1A.3. These are both an x. And then I have to add my exponents in this case. Right? Again, that's going back to 1A.3. I would expect you to use a calculator for negative 64 times 4, but your answer is negative 256. Right? Doing that. This is a variable, and then type in this. 12 plus 10 is 22. And that is our answer. All right, looking at example 7. This is a power problem, right? We just have lots of bases. So our first base is this 5, and it has 1 and 4. So 5 to the 1 times 4. X has 2 and 4. Y has negative 3 and 4. And then our Z has a 1 times 4. Okay. So now, simplifying in the next step. This has no variables in it. So 5 to the 1 times 4 is 625. Again, I'd expect you to use a calculator, but save some time. And then X is a variable, can't do anything. 2 times 4 is 8. Y is a variable. Can type this in and we get negative 12. Z is a variable, so we type this in. And 1 times 4 is 4. Now the only thing is this Y has a negative exponent. So the negative cancels out and we have to flip it down. So everything that doesn't have that negative stays up. So we have 625, x to the 8th, z to the 4th, over y to the 12th. Okay, only the y flipped down, so it's the only one that has a negative. Alright, last problem is a division problem. Again, we looked at division in 1A.3. So we want to do 4 over 12. Okay, so I'm just going to keep that as 4 over 12 for now. Then I have an exponent of m. This one's bigger, so my m's going to go on bottom. 2 minus negative 2. With my n's, I have negative 5. And then the n on top has a 1. That one's bigger. N's going to go up here. 1 minus negative 5. And then we have p's with a 3 and a 1. This 3 is bigger. Right? So p's are going to go up here. 3 minus 1. Using a calculator, 4 divided by 12 is 1 over 3. So when I draw my fraction bar, we're going to have 1 over 3 n. 1 minus negative 5 is 6. Again, be careful with you should have a minus and a negative in your calculator. And then p, 3 minus 1 is 2. M, 2 minus negative 2 is 4. And there is our answer. And that is it. All right. Go ahead and work on your 1A.5 activity. When you are done with that, it is then time for your 1A mini quiz.